Course T216B CCNA 4 Connecting Networks, Chapter number 8, Monitoring the Network. In this lesson, we are going to talk about syslog or system log, SNMP or a System Network Management Protocol, NetFlow, and we will end up the session with summary. The main objectives of these lessons are: what is a syslog? How syslog operate in a small to medium sized business network, how to configure and compile a syslog messages on a small to medium sized business network management device, how syslog operation in a small to medium sized business network, how to configure simple network management protocol to compile messages on a small to medium sized business network, how the NetFlow operations in a small to medium sized business network, how to configure a NetFlow data export on a router, how to examine the sample NetFlow data to determine the different traffic patterns. Syslog or system log. Introduction to syslog. Syslogs are the different system messages which are generated and to be configured on a specific computer known as a syslog server, which basically records all these system messages. Syslog operation. As you can see in this presentation, we have a syslog message destination options, we have a logging buffer, we have a console line, we have a terminal line, and we have a syslog server. These are the different message formats of a syslog. We have a severity name like emergency, alert, critical, which are identified by the severity level such as level 0, level 1. An explanation: level 0 is a system unusable, level 1 is immediate action needed, level 2 is a critical condition. And in a syslog message format, we have a different field such as sequence number, which stamps log messages with a sequence number only if the service sequence number global configuration command is configured. Similarly, timestamp, the date and time of the message or event, which appears only if the service timestamp's global configuration command is configured. Then facility, severity, mnemonic, and description. Service timestamp in a syslog operation, it logs the messages, and all the messages can be timestamped, and the source address of the syslog messages can be set. This enhances real-time debugging and management. The service timestamp log date time command entered in a global configuration mode, it should be entered on the device. So in this chapter, it is assumed that the clock has been set and the service timestamp log determine command has been configured on all the devices. Syslog server provides a relatively user-friendly interface for viewing the syslog output. The server passes the output and places the messages into predefined columns for easy interpretation. If timestamps are configured on a networking device sourcing the syslog messages, then the date and time of each message displays in the syslog server output. The network administrators can easily navigate the large amount of data compiled on a syslog server. Default logging. If we issue a command on a router such as show logging, is going to give us the messages such as the syslog is enabled. And we can see in this example here, the console logging is a level, debugging, and 32 messages logged. And by this way we can interpret the messages such as buffer logging, and the date and time has been mentioned on which date and time the syslog has configured. Similarly, routers and switch command for the syslog clients. On this router we have enabled the command logging on this IP address, logging trap 4, and logging source interface, which is the gigabit ethernet 0/0 and interface loopback 0. Then by issuing a command no shutdown, shutdown, and then no shutdown. In order to verify the syslog, we can issue a command show logging, which includes the change state to up, and then we can see show logging and then begun. SNMP is a simple network management protocol which is used to manage different messages on the network devices and in turn sends the messages back to the administrator station, which is known as SNMP manager. Different messages or agents can be configured on a managed node, such as SNMP agent on a managed node, SNMP agent on a switch as a managed node, and SNMP agent on a firewall as a managed node. We can configure the different traps by issuing a get and set commands. SNMP operation: all the informations done in the SNMP provides the different operations, such as a get request. This retrieves a value from a specific variable. Get next request retrieves a value from a variable within a table. The SNMP manager does not need to know the exact variable name. A sequential search is performed to find the needed variable from within the table. Get bulk requests, get response, and set request. So these are the various operations that can be configured on an SNMP server. Then we have a different types of SNMP agent traps between SNMP manager and a managed device, such as get request. This retrieves the value of the specific message information base variable. Get next request, this provides a next instance of a message information base variable. Set request, get response, and trap. The different versions of an SNMP. SNMP version 1, it's a simple network management protocol which is defined in RFC 1157, a full internet standard. SNMP version 2C, which is defined in request for commits 1901 to 1908. It utilizes community string based administrative framework. SNMP version 3, it's interoperable in standard based protocol, originally defined in RFC 2273 to 2275. This provides secure access to devices by authenticating and encrypting packets over the network. It includes these security features, such as message integrity to ensure that the packet was not tampered with in transit, authentication to determine that the message is from a valid source, and encryption to prevent the content of a message from being read by an unauthorized source. Community strings: there are two types of community strings configured in SNMP. Read only: this provides access to the message information base variables but does not allow these variables to be changed. Only read. Because security is so weak in version 2C, many organizations uses SNMP version 2C in read only mode. Read and write: this provides read and write access to all objects in the message information base. This is how the management information base objects works in SNMP. Different steps for configuring SNMP. Step number 1: required. Configure the community string and access level, either read only or read and write, with the SNMP server community string, read only or read and write command. Step number 2 is an optional. Document the location of the device using the SNMP server location text command. Step number 3 is also optional. Document the system contact using the SNMP server context text command. Step number 4 is optional. Restrict SNMP access to the NMS hosts that are permitted by the access control list. Define the ACL and then reference the ACL with the SNMP server community string access list number or name command. Step number 5 is an optional. Step number 6 optional. Enable the traps on the SNMP agent. In order to verify the SNMP configuration by using the command show SNMP, and this shows us SNMP packets and traps, and show SNMP community. Security best practices: manage routers with SNMP and syslog agents, manage switch with SNMP and syslog agents, manage switch with SNMP and syslog agents, and NMS using SNMP to monitor and manage the network devices. NMS, or a network management system, also receives syslog messages from the network devices. NetFlow is used to analyze the traffic flow. NetFlow should be configured on a administrative station to collect and analyze the traffic flow. The purpose of the NetFlow: most organization uses the NetFlow for some or all of the following key data collection purposes, such as efficient measuring who is using that network resources for what purpose, accounting and charging back according to the resource utilization level, using the measured information to do more effective network planning so that the resource allocation and deployment is well aligned with the customer requirements, and using the information to better structure and customize the set of available applications and services to meet the user needs and customer service requirements. Network flows. Net flow technology has seen several generations that provide more sophistication in defining traffic flows, but original net flow distinguishes flows using a combination of 7 key fields such as source and destination IP address, source and destination port number, layer 3 protocol type, type of service, TOS marking, input logical interface. Net flow configuration tasks. On a router where we would like to configure the net flow to the specific interface, in this example interface gigabit ethernet 0/1, IP flow ingress, IP flow egress, exit, and then IP flow export destination by giving the IP address and port number, and IP flow export version 5. In order to verify the net flow, we can issue a command show IP cache flow, which basically shows the total packet size distribution and the interface where the net flow is configured. Similarly, we can use the command show IP flow interfaces and show IP flow export. Then net flow collector functions to filter and to aggregate and send the information back to the storage. This is how the net flow analysis with the net flow collector, a GUI interface. Summary of chapter number 8. In this chapter we talked about syslog, SNMP and NetFlow, which are the tools used by a network administrator in a modern network to manage the collection, display and analysis of events associated with the network devices. Syslog provides a rudimentary tool for collecting and displaying messages as they appear on a Cisco device console's display. SNMP has a very rich set of data records and data trees to both set and get information from networking devices. NetFlow and its most recent iterations such as flexible NetFlow, it provides a means of collecting IP operational data from IP networks. NetFlow provides data to enable network and security monitoring, planning the network, analysis the network traffic and IP accounting. NetFlow collectors provide sophisticated analysis options for NetFlow data. This concludes our chapter number 8. Thank you for watching.